In previous video, we discussed about the value of J may vary because of the four criteria. Now we will discuss the four criteria. First one is altitude of the place. The value of G varies with the distance from the center of the earth. So the value of G is varies due to the variation of distance between center of the earth, mass and the body. So first we can we can here we can find three cases. First case is object on the surface of the earth. Object on the surface of the earth. So here we see the graphical example. So suppose this is our earth and this is the center of our earth, C. Okay, and the distance between the center of the earth and the surface of the earth is suppose R, and this is our body which has mass of m, and the mass of earth is capital M. So in this case our gravitational equation is, or our gravitational acceleration equation G is G equals to G m by r square. So in first case this is our equation when the object is on the surface of the earth. Now the second case is object above the surface of the earth. Object above the surface of the earth. So what that means, suppose this is our earth E, which has a mass of capital M, and this is our center, and this is the radius of our earth, and a body is at the distance of h above the surface of the earth, which has a mass of m. At that case our gravitational force G of h equals to Gm by r plus h whole square. And when the, so this is our equation 1, and when an object is on the surface, when this object is on the surface of the earth, so I represent it as yellow, green. So when this object is on the surface of the earth, then at that case our equation G will be Gm by r square. So there we can see the gravitational acceleration is different is this in this both case. So if we find out any relationship between them, suppose we divided this 1 with 2, we'll get gh by g, which is equals to r square by r plus h whole square. Or you can write this thing as r equals to 1 plus h by r whole square. R square equals to 1 plus h by r whole square. Or we can write this thing as 1 plus h by r whole inverse 2. 1 plus h by r whole inverse 2. So let me clear this 2 point. So if we expand this binomial expansion, then we'll get gh by g is equals to 1 minus 2h by r. We actually we will not consider the greater term of this expansion, because we know our is h will be always less than r. So it is, the h is very smaller than r. So at this case we actually doesn't consider the third, fourth, fifth expansions. Okay, so we only consider this part. Then we'll get g of h equals to g into 1 minus 2h by r. And we know our gravitational force will always be positive. So at that case, we find out that here this term will be less than 0, less than 1. This term will always be less than 1. So at that case, this whole term will be that will be an small value. So this whole term will be a small value which is less than 1, which is less than 1. So if I multiply something with less than 1, then I will get smaller value. So at that case, we find out that when the body is at the surface of the is on the surface of our earth, and when we take the body at a distance of h above the surface of the earth, then their gravitational acceleration will be lesser, or we can say that it will be decrease. So we we can conclude that the object above the surface of the earth will be less gravitational force than our when our gravitational force when the object is on the surface of the earth. So this is our second consideration, when our object above the surface of the earth. Now coming to the next one, which is when the object situated when the object situated below the surface of the earth, below the surface of the earth. So suppose this is the surface of the earth and this is the center, and a body is at depth from the surface of the earth, and the distance between this object and the center is suppose h. No, sorry. The object is at depth of h, at the depth of h. So we just consider this circle to calculate the value of this value of our body from this portion to the center of the earth. Here, as it is h value, and we know the radius of our uh, radius from the radius of our earth is r, so we can find out that this value will be r minus h. So this value will be r minus h. Okay, so what we just draw? We just draw a body which is at the depth of h from the surface of our earth. Now now uh, now we know for now we know an equation which is, we know the formula of density rho equals to m by v, or you can write this thing as m equals to rho v. And we know the formula of calculating the volume of a spherical object is 4 by 3 pi r cube. 4 by 3 pi r cube. So what will be the mass? What will be the mass of our earth, which is an spherical shape? So it will be equals to which will be equals to rho into 4 by 3 pi r cube. Suppose this spherical the volume of this spherical is m prime. So what will be the volume of this what will be the mass of this spherical is m prime. So what will be the equation for this m prime value? It will be equals to rho into 4 by 3 pi, and instead of r we will use r minus h whole cube. R minus h whole cube. So we find out these two equations. Let me write this thing at the upper side of our finding. So we can write this thing as m prime is equals to 4 rho into 4 by 3 pi r minus h whole cube. Okay, and what is the rho? Rho is the density of our earth. Rho is the density of our earth. So we know at the depth of h, the formula will be g of d equals to g. Here we will consider the value of this spherical, because when the depth is when the object is at depth, then we will consider the spherical calculating at that depth. So this is our sphere. Okay, so we will consider our value of m equals to m prime, and our distance is r minus h whole square. R minus h whole square. Now we will put the value of m prime, then we will get g into rho into 4 by 3 into pi into r minus h whole cube divided by r minus h whole square. Okay, now if we simplify this thing, then we will get g of d equals to 4 by 3 pi g rho into r minus h. Here this is a constant value, pi is also a constant value, g is also a constant value, and rho, the density of our earth, is also a constant value. So we can replace this whole constant value with a value of k, okay. So from this above equation, when our h is increasing, this h is increasing, our g of d will be decrease. So with the increased depth from the surface of the earth, g decreases. So we can say that when increase of depth from the surface of the earth, then our gravitational acceleration g will be decreasing. So it will be decreasing. And when h is equals to r, then our g of d will be 0. So at the center, the gravitational acceleration is 0. So we find out this conclusion from that above equation. So if I draw a graph, suppose this is our, here the y-axis represents our value of g, or gravitational acceleration, and this is represent the distance from the center. So this is and this point actually means center, and this is the radius of our earth, and this is subpoint h. So from the center to the radius r, our gravitational acceleration will be increasing in straight line. And from this section, our when this is the surface, because this is the surface of the earth, and from the surface of the earth, if we go above, then the gravitational force will be decreases exponentially. So this graph actually represent the altitude of the place for the three case. This is the decreasing straight line, and this is the decreasing exponentially from the surface of the earth. So our gravitational acceleration is working according to this graph. Okay, I hope you understand the altitude of the place for the now I think you will understand the impact of altitude of the place on the gravitational acceleration. Okay, now our second one is non-spherical shape of the earth. So we know the shape of the earth is not exactly spherical. Our shape of the earth is not exactly spherical, it is something like that. So it means it's polar regions. So these regions and these regions are bit flattened. So these are a bit flattened. On the other hand, its equatorial regions were slightly bulged. So this equatorial region were slightly bulged. This is a 2D view. If you please go through the 3D view in the YouTube to understand better of this concept. Okay, hence the equatorial radius is slightly more than the polar radius. So this equatorial radius, suppose we take this as r of e, and this is polar radius r of p. So our equatorial radius will be a slightly greater than our polar radius. So now we know g at a place is inversely proportional to the square of the radius of the earth. We know the g is inversely proportional to the radius of the earth. So we can find out that the value of g at the poles is greater than the value of g at the equator. As this is lesser than equatorial radius, then our in at the polar section our g will be higher, instead of on the other hand at the equatorial section our g will be lower. So this is the impact of non-spherical shift of the earth on the gravitational acceleration. In our next video, we'll discuss about the rotational motion of the earth and mass and density of the earth, which impacts the gravitational acceleration. I hope you understand the whole concept of this uh, gravitational variation of gravitational acceleration. Please like this video and subscribe to our channel. Thank you.